Hello everyone, welcome to my channel. Up to this we read about the refraction of light through plane surface and refraction of light through prism. Today I am going to talk about some application of refraction of light in our real life. So let's start. One or two examples I am giving. There are so many applications and the first example is when a coin is kept in a vessel, it is not seen when it is viewed just from below the edges, but the same coin it can be viewed when the water is full. Or another example I can give, a tank appears shallow than its actual depth. To understand the concept of refraction of light or the application of refraction of light, you have to learn two terms, which is real depth and the apparent depth. So let's start from these two topics. To explain this, I am taking one container which is filled by the water, and this layer is the water air interface. This is water, this is air. Okay, and a coin is kept at the bottom. So many rays will come from the coin. I am considering two rays out of this. One ray which is falling normally and another ray which is making some angle. Now one thing we read, when the rays goes from denser medium to rarer medium, denser to rarer, then two things changes. One is the speed of light increases and the light bends away from the normal. Here in case of this one, when the ray falls normally, then it undeviates its path, means it will not change its direction. What will happen in this case? Here if you draw the normal, then this ray will bend away from the normal. Okay. Now, if we see from this region, then it seems this coin is placed over here. Means it seems it has raised. Now, see, these two rays cannot meet. If we extend it, these two rays cannot meet. So, in here, the image will not form. So, where the image will form? So if we extend it backward, these two rays are meeting at this point. That's why it seems this coin has raised up to this much. So when it is viewed from this position, then here I am giving the name O and here I am giving the name I. So it appears to be coming from the point I. Okay, and one thing, if we give this point is A and this point is B, actually these 2 points are very close to each other. But for explanation, I gave some gap. Now, these two rays actually, it comes to the eye simultaneously. Okay, but here for explanation, I have given some gap. Now, what we did? When it is viewed from this position, it appears to be coming from the point I. Okay, see. What was the actual position of the coin? This is means from A to O. So AO we can write, this is called the real depth. And by the eye, it is appearing at this point, when it appears to be coming from this point. So this AI is called the apparent depth. Okay. This AI is called the apparent depth. Now one question will arise, how much it has been shifted? This much. So this OI is called the shift. Okay. This AI is called the shift. So AO actual depth or real depth, AI apparent depth, and this OI or IO is the shift. To derive the relation between real depth and apparent depth and the mu means the refractive index of the denser medium. Here I took water. You can take any denser medium than air. See here, this angle will be the angle of incidence, means I is the angle of incidence, and this R is the angle of refraction. See from this diagram, so angle OBQ equals to I, which is equals to this angle. Why? Because this PQ and OA is parallel and this BO is the transversal. So this I angle will be this angle because of alternate angle. So equals to angle AOB. AOB. Now see, if this angle is R, so this angle will be I. This angle is R, then which angle will also be R? This angle will also be R. Why? Two reasons I can give. One is PQ and RO, these are parallel, and this I, suppose C, this is C, this IC is a straight line, this is a transversal, so this angle will also be this angle. Otherwise you can take, as this is R, so this total angle means from here to here, this angle will also be R, and these are alternate. This is also similar case. So angle, just one I am writing, AIB, this angle is R, where this angle is I. Take the triangle. Which triangle I am taking? Triangle AOB. AOB, I can write this angle is I. So from here, sine I will be base by hypotenuse. So in this case, base will be AB, hypotenuse will be OB. Okay. Now take the another triangle which is AB and I. Triangle ABI. Here sine R equals to base also AB and the hypotenuse is IB. Okay. Now do sine I by sine R. See one thing, it is going from rarer to denser medium, means medium to air. That's why I am writing, suppose water I have taken. So here W, instead of W you can write M also, because medium, any medium. So I am writing here W or medium you write. Medium mu A means the refractive index of air with respect to medium, because the ray is going from denser to rarer medium. That's why medium to air. If the rays comes from air to medium, then A mu M. Okay. That's why here I have written here M mu A. It is equals to sine I divided by sine R from the Snell's law of refraction. So sine I by sine R, you do it, it will come AB by OB into IB by AB. AB will cancel out and it will give IB by OB. Okay. So one thing we did, 1 mu 2 equals to 1 by 2 mu 1. So here A mu M will be OB divided by IB. See, first I told A and B, they are very close to each other. So whatever be the distance of AO, that is same as the distance of OB. So instead of OB, I can write OA divided by IB, I can write IA. So here OA means actually which one? This is real depth, divided by IA means this is apparent depth. Okay. So the relation between real depth and apparent depth is real depth equals to the A mu M into apparent depth, or apparent depth equals to, this relation also correct, or you can write this apparent, here I am writing this apparent depth equals to real depth by mu, means obviously A mu M, because refractive index of medium with respect to air. This is the relation between apparent depth, real depth and the mu. Now to calculate the shift, which relation you have to apply? See, AO was real depth, AI was apparent depth. Shift how much? IO. So IO we will get, see, this is called the shift, which is OI I am writing here. OI equals to AO minus real depth minus apparent depth. So this is AI, means real minus apparent depth. Now AO equals to AI, or apparent AO means real depth minus apparent depth. Okay. Now apply the formula over here. This is real depth minus apparent depth is real depth by A mu M. So real depth take common, then 1 minus 1 by A mu M. This is the relation of shift. Okay. This shift depends on some factors. First factor is the refractive index. How the relation? The relation is when the refractive index increases, that shift also increases. How? Here I am considering two medium. Here suppose this is water and this is the glass and air. So in safe distance I am considering the one object is placed over here. At the same distance I took. When the rays goes from denser to rarer medium, this is water, air. Water is a denser, optical density is more than air. So here if you draw the normal, there will be a bending away from the normal. Suppose this is the refracted ray. Now if we extend it backward, then this point, suppose O, here I am giving O dashed. This point, it appears to be raised up to O dashed. Okay, means it seems this O point is coming from this O dashed point. So shifting how much? This is the shift. Now in this case what will happen? See, this is the incident ray, but optical density of glass is more than optical density of water. That's why the bending will be more. So this is the bending. Now if we extend it backward, so this is the point O dash to suppose O double dashed. Now see how much the shifting. This is this much. Now easily we can say this shift means O dashed, O double dashed is more than O dashed. So why? Because the optical density of glass is more than the optical density of water. Second factor is the thickness. How the shift depends on the thickness? There is also same explanation. When thickness increases, shift also increases. T I am writing for thickness. Okay. And the third factor is the wavelength or color. Okay. I am writing the lambda. Here this is inversely proportional. Means that shift decreases in increase of wavelength. Why? One thing you know, lambda for violet, it is less than lambda for red. And that's why this mu for violet, it is greater than the mu for red because of inversely proportional. Now that's why as this mu for violet is more, for mu it will suffer more bending. Means more bending means more shifting. Okay, more shifting, understood? Again I am telling, see, more shifting means two things example I am giving. Suppose the ray is going from here. Suppose here the bending is less, that's why, see, obviously the medium will be different. Okay, for explanation I am telling. Suppose this much it has shifted. Okay, and the second case, suppose in another medium, this is normal, the ray is going like this and the bending is more. More bending, see, angle is more, angle of refraction is more. So here if you extend it backward, see how much it has shifted. This much. That I am trying to explain. So when the bending is more, there will be more shifting. As the refractive index for violet is more, there will be more bending. So more bending means more shifting. So that's why we can say for this wavelength, the shifting or the shift increases or the shift decreases in increase in wavelength. Okay. One example I took where the refractive index of glass is given 3/2. Means the thickness of the glass, it appears 2/3 of the original depth, means of the real depth. Why? Because the formula of apparent depth we know, that is real depth by mu. So put the value over here, that is 3/2, which is 2/3 of the real depth. So the apparent depth will be 2/3 of the real depth. Now one important application I will explain that sometimes that comes in the board. The bending of stick under the water. See, when a stick placed under the water, then when it is viewed from air, it seems it appears to be shortened. Means there is a bending. It seems there is a bending, but actually it is not. Why that I am explaining. See, suppose this is the other end. Okay. So from Q, so many rays will come out of these two I am taking. So when the rays comes from denser, this is water, denser to rarer medium, always it bends away from the normal. Now one thing you see, these two rays cannot meet. If we extend it also, they are diverging rays, that's why they cannot meet. If we extend it backward, they are meeting at the point of Q dash. So it seems this Q has reached to Q dash, means there is a shifting. So that's why it seems, means when it is viewed from air, it seems this Q point, it appears to be coming from this Q dash point. So the OQ part, means the emerge part, appears to be OQ dash. That means the emerge part appears to be raised. So therefore there is a bending at the point O, means water air interface. So the stick, means POQ, appears as POQ dash. Okay, this is all about the real depth and apparent depth and some application. In next class I will start the critical angle and the total internal reflection. Thank you.